Hello, my name is Joseph and my project partner is Kaleb. Our ME100 IoT project is the lazy egg cooker. An increasing issue that's plaguing college students across the world is that they're forsaking their health in the name of maintaining their grades and their social life. While the goal of our project is not necessarily to educate college students about healthier life practices, our goal is actually to make eating healthier food more accessible to college students. And we're going to do that starting with cooking an egg with our lazy egg cooker.
Here we just have some code overview. The first thing we need to do is import different classes that we'll use later on in the code. Here are just some variables that we assign to frequencies that are used in our block from an earlier lab. We'll see that come into play later. And then we also need to connect to MQTT. We do that via boot.py. And then MQTT uses the Adafruit website. And once it's connected, it'll print connected into our terminal. And then this is our actual actuators. We decided to go with 3 in this project. The first one is an LED to indicate when the water is actually boiling. The second one is a speaker to indicate when the egg is done cooking. And the last one is a servo to turn the knob on the stove to off, ignite, and high, which are these 3 values. These 3 values are actually duty cycle values that we found. So the first thing that happens is that the servo, like I said earlier, it starts from off, which is the default, and it goes to ignite, holds it for 3 seconds, and then goes to high, holds that for 2 seconds, and then de-inits it so that the servo turns off. And then we enter a while loop. In this while loop, the sensor is actually constantly outputting values into our terminal, like so. And then once it exceeds our boiling temperature, which is just an arbitrary 30 for now, it'll exit the while loop, and the LED will turn on to indicate that the water is boiling. Our formula has the water boiling for 90 seconds, but we did 60 for time's sake. And once 90 seconds is done, that's its intermittent phase, and then the value of 0 will be sent to our MQTT, which is connected to IFTTT as a trigger. And this trigger will then send an email to us saying that the egg is halfway done. And then it'll sleep for another 90 seconds, but in this case we use 60 for time's sake. And then one will be published into another feed on MQTT, and then another trigger will go off in IFTTT. And this will subsequently send us an email telling us that we need to go get our egg, or a text. We use both in this project. And then afterwards we have the servo turn off, right, to the off duty cycle, and then the buzzer goes off the speaker goes off playing Bach, right, and then last but not least the LED turns off.
Okay, so the order of sequence of events is that the user needs to put the egg into room temperature water, and then once they can start the code. The stove is currently at the off position, as you can see, and the LED is off to indicate that the water is not yet boiled. When it starts, you go to ignite for 3 seconds, and then go to high. Now it's at high, I start outputting values. We use 30 as our threshold, so 52 exceeds it, and that indicates that the water is boiling, and it is represented by the LED that has turned on. Once the LED has turned on, there's a 30-second timer that has commenced. It's realistically going to be a minute and a half. We use 30 seconds for time's sake. After that, another 30-second timer will commence for the latter half of the cooking phase. And once that's done, the stove should automatically turn off. The value of 1 should be recorded. The speaker will go off to indicate that the egg is done, and then people can come. As soon as the sound is over, the LED will turn off, and the user will get another email to tell them that, or a text, that the egg is ready. Here are the emails. Egg is halfway done. And then the other one is your egg is done.